Resting membrane potential and action potential by Sakurasata period 2. I'll be explaining how neuron transmits signal to our flexor digitorum superficialis muscle, starting with the dendrites, sending in information into the cell body. In the cell body, they get ready to send a signal, and this is called the resting potential. The resting membrane potential will become grading potential, and before the action potential takes off, we have two ions at the axon. We have the positive sodium ions and we have the positive potassium ions, and it also includes sodium potassium ATPase. The sodium potassium ATPase are pumps that maintains resting potential. So when the neurons at the resting potential, that's where there's only negative ions in the axon. Once the action potential ignites, the positive sodium ion gate or channel open, letting the sodium into the axon, and when the signal has reached its peak, and this is called depolarization, the anti-channel closes and the potassium channel opens, causing the potassium to leave, so the potential returns to resting, and this is called repolarization. As the K channel leaves open, it will result as hyperpolarization, and so the sodium to potassium pump will bring it back to normal. The signal reaches at the synaptic terminal where the presynaptic cells sends the neurotransmitter and the postsynaptic cells receives the message. In this case will be the muscle cell. Finally, the acetylcholine reaches the receptors on the muscle sarcolemma, increase an impulse, and travels down the membrane and into the T-tubule. Then it releases calcium ions and move on into the sarcoplasmic reticulum. From there, the calcium ions can unlock the gate and have the muscle contract. It'll all make sense once I demonstrate it with this stop motion.